Swayam Prabha. Digital India. Educated India.
Good morning. I hope you have enjoyed till whatever I have discussed. As I promised, now we are gradually entering into the design parameters. Whenever we are trying to design a landscape, what happens is we have been given a site. The site owned by our sponsor. We say a typical term called client. Client has a site which he wants to develop as a landscape project, and you are the designer. You have been now approached by the client for designing this particular landscape. Try to understand this. Once he comes to you and then he expresses that what is the kind of design, then immediately one question you have to ask him, that what kind of landscape project are you envisaging? What kind of landscape project do I have to prepare for you? Or what is in his mind, or what is at the back of his mind, or what is the kind of thing he covets, what he doesn't want. So basically what happens is, whenever a project comes to you, you try to understand the project. For understanding the project, we call this as a design brief. So the design brief he gives. Now as soon as the design brief is given to you, let me just give you a sequence. The client comes to you with a design brief. This design brief of a landscape project, because our focus is on landscape. He comes with the idea, okay, the landscape project that we are going to do. The moment he says this, you will ask for the design brief from him, and the design brief will tell you what kind of functions to be located where, that means the location, and the client's dreams, what he is trying to get out of it. Unless you understand these three things, you will not be able to design. What is first? The function. What function he wants. Location may be the next. Somebody comes and tells you, I want you to design a resort which is in a large area full with more of greens, and the resort which people will come here to relax for a few days and enjoy the landscape of it. That is the kind of thing he might have said. I can also assure you one thing, the client may be coming with a design brief sometime, or sometime client may not be very much prepared, or may not be learned about it, or very much knowledgeable about it, what he wants. He may have a vague idea, and he will come to you and express that this is the kind of thing which I want. This is fair enough for you as a professional, fair enough. The moment somebody is opening his dreams to you, then immediately you can, from your own knowledge, background knowledge, your research, you would be able to find out, okay, if this is the kind of dream he has in a site that he is bringing into me, and then this may call for this kind of functions. Some of them he has named, but many of the other functions which can come in which he did not name, you can suggest. So this is how the whole process starts. So the dialogue between the owner and the designer, landscape designer, at the initial stage makes a very big difference. At that point, owner may not be able to clarify all. At that point, you as a landscape designer should assist him and try to give him clue that okay, this is the kind of project you are envisaging, then this should also have these things. Client may come up with some predetermined idea, preconceived idea. He may say, I want this, and you may find that in that particular location or that particular site, it may not be very suitable. Then it is your responsibility to educate him, convince him, saying what is the negativeness of that particular project. What happens is the client generally goes to some other landscape sites, looks at it, gets impressed as a viewer, as a user, and then dreams of making a landscape site for his own, and then he tries to tell or express to the landscape designer, communicate to the landscape designer saying that these are the things I want. Landscape designer might then, at that time, since he is trained, will try to find out that what are the things which are not good for this particular project, what are good for this project. So what happens is, before this site investigation, that particular step comes in, and I did not really focus much on that for a very different reason. It is only a very short meeting within which you can come to know what are the functions you want. Then comes the location you have known. Once you have the location, then your next very important responsibility prior to planning is this stage, site investigation. This is what I have listed here in the screen: site investigation, analysis, and appraisal. Today's discussion will be focused on this. What is the site investigation we are talking about? Client has come with a design brief, which is a printed document. Client may also come with some kind of pictorial representation through photographs, or maybe a video, and now you are trying to understand it, view it. But you are going to design on something which is going to be translated over there. So at this particular stage, this site investigation is very, very essential. So this site investigation, or rather I would say site analysis, is very important. This analysis will have first the investigation part, and then the analysis part, and then the appraisal part. So it will call for investigation. What is that investigation? Investigation is basically nothing but trying to know about the site. What is this analysis? I am saying very simply, investigation is trying to know about the site as much as possible. Analysis is trying to analyze the potentials and constraints of the site, whether it's visual, physical, functional, environmental, all aspects. So you are trying to analyze this with respect to such parameters. And appraisal is, after analysis, whatever you have inferred from there, that is appraisal. Now I will show you in terms of first step, site investigation. Survey, which basically makes a very strong component of the investigation. In that, if you see in my list here, the first one is reconnaissance survey, the second one is physical land survey, third one is aerial survey, and the fourth one is remotely sensed survey. Not that in your landscape project site you will get opportunity to do all, not necessary. It all depends on the scale. It all depends on how much is the domain of your landscape site which you are trying to investigate on. How do you go for this? Reconnaissance is when you go yourself to the site. You means you or your trusted representative who is going to bring back the visual pictorial representation to the best possible manner so that you can comprehend sitting over here. Personally, I can tell you what I do. I never rely on anybody else if I am the designer. I don't rely on anybody else's reconnaissance survey. I will go myself to the site. I will look around the entire site as far as practicable. If it is too large a site, it happens for landscape planning projects, is a large site. But for normal standard landscape projects, you can walk from one corner to another. Rather, you can move from the entire stretch of that particular landscape project site. When you see this, you do a reconnaissance survey. A very common term used for this is called recce. You might have heard many of your friends, professionals, they are saying, I did a recce of the site. Basically what his meaning is that he has done the reconnaissance survey of the site. In the reconnaissance survey, what you do is, say this is a site. You try to view the entire site from this particular viewpoint once, look towards this. From here, try to see this part. From here, try to see this part. From here, you try to see this part. So basically, you are trying to see the entire site from different corners, maybe. Not that every time that the corner will be very easily accessible. So my point is, it's not the corner or the edge, it is the vantage points from where you can get the best comprehension of this. So here, another term that comes in is basically the comprehension. So reconnaissance is for your own comprehension of that site. There are many ways of doing. Different designers use different methodologies for comprehension. Somebody looks at it, takes quick photographs. Somebody takes individual shots. Somebody takes the serial shots, walking from one particular point to another. Somebody takes a video shoot of the entire. Somebody takes a panoramic view of the entire. So there are different ways of doing it. Somebody focuses on something very interesting in that particular site. So the reconnaissance basically means that as much as pictorial reserve or say documentation that you can do, that's what is a reconnaissance survey. It helps a lot. I'll tell you, it helps so much that many of your design ideas crop up at that particular stage itself. Okay, so when you take this into consideration, go on into the site. If possible, if you have any site, or if you don't have a site but you just hypothetically try to see this exercise, you can go to any nearby park thinking that the park is going to be redesigned by you, and you do the reconnaissance, then you will realize what I am saying. You walk in from whichever point. You may be standing at the center trying to look around. You may be standing at one corner trying to look at the panoramic view. If the site is undulated, try to see the tilted view. If the site is undulated downward, try to see tilted down. So point is, you are trying to document the entire visual points. Why it is important? When you are seeing it, I'll tell you, I can assure you, at the first shot itself, many of the ideas will immediately crop up at the back of your mind. Immediately. It's a split-second reaction. You may maintain it, sustain it, or you may change it. But some ideas will come there, I'm sure. For landscape projects especially, or for architectural side, I may not comment that way. Well, sometimes it happens that many of my designs, when I went for reconnaissance survey, many of my designs cropped up there itself in my mind, and I found that I am quite true to that particular reactions, and I could not deviate much, because that the first idea that comes in your mind is pure, raw, and it evolves from the site. So for landscape, it is all the more true. When you look at it, then immediately many of the ideas crop up. What you do is, at this particular stage, during reconnaissance, you take notes of all those. If the idea is coming in your mind, take note of that idea which is coming. Record it. Don't leave it at the back, trust your memory, because after some time when you will sit down to plan, you might have forgotten that, or you may not have that first reaction recording, and whenever you are trying to re-look into it, you might find that no, I thought at that point of time, but now it is not, because you are still not in the same sensory modes at that particular point. So what you do is, in the reconnaissance, you move around the entire site, take note of all positives and negatives, potentials and constraints and limitations, strengths, weaknesses. You know what we say as SWOT analysis: strength, weakness, opportunity, and threat. Similar, but there we always try to find out what are the threats. In landscape projects, the threats are minimal. So I won't use that SWOT for here, but the thing is, similar kind of mindset works at this particular point. Okay. Once you have done the reconnaissance of this particular site, then you assign surveyors to do the survey of this site, and that is the physical land survey. What the physical land surveyor will do, basically what you want, the project that you have, say this is your site, you need to get exactly the dimensions of each of this edge and the angle. This you need to get, this length and this angle, and this is called in the physical land survey the traverse, which will create a base map. Now, here your role is very important. What you have to do is, you have to give a very clear idea to the surveyor that what all he must not miss in documenting. Just like as you have said, this point, this is a traverse dimension, this dimension, this length, internal angle, external angle, everything which will make absolutely a true representation in diagrams whenever you are trying to reproduce this. So, the base map that you are preparing, you are suggesting your surveyor that exactly what all information he has to have. As it is, he will have all this information. That is why you will find that this kind of base map will have, say, if you ever must have seen a dimensional drawing of the base map, in this you will find this is one dimension, this is another dimension. All these are the dimensions that will be recorded here, okay, and the angle. Along with this, there are many other features which are contained within, has to be recorded. What kind of features? First of all, the topographic features. If suppose this particular area is not flat, it is contoured, in such case the topographic factors that you need to have. You need to have something called contours. You need to have this. When you have the contours, these contours are not a physical line in sight. These contours are notional elevations, uniform elevations along this particular line. These are not the notional lines seen on the site. How the surveyor will do it? He will find out the spot elevations of different portions. It may be uniformly made with grids, and the intersection points at that he will try to find out the elevations, spot elevations, and then from there interpolate or extrapolate these contours. And once he gives you the contour line, also has to give you a level, this level. There are two things. One is the level. This level is going to represent what is the elevation of it. And there is another thing which is level. This level is nothing but annotation of it. That means if it is said that suppose somebody is saying this is 100, then 100 is the elevation and this is say 99. Considering that this particular drop is 1 meter, this 100 is the level, 99 is the level, 100 is the level, both are levels. So, these sometimes nowadays we are using the term called annotations. Okay, by annotations this is depicted. Why it is important? I have just covered these two levels. If now you look at the contour drawing, you will not be able to tell me which side is up, which side is higher, which side is lower. This is very, very critical. If suppose I just change from this 100 to here and 99 here, the whole side goes in this direction, this slope. And if I say this is true, then the whole side goes in this direction. This is very critical. So, whenever you are asking the surveyor to do the survey, he is going to find out the spot levels. So, spot elevations. When he is trying to find out the spot elevations, here this one more thing will come in. Spot elevation at what interval? So, all the physical land survey which started with a chain survey and all that, there are many more developments and a different kind of equipments have come, or rather been devised, evolved over time, which are giving us more comfort and more accurate information. We have chain survey, we have plane table survey, we have prismatic survey, we have theodolite survey. Nowadays we are using total station. The point is these are different survey equipments at each point of time with the limitations of that machines or equipments. Whatever level of precision that was achieved was being done. Okay. So, if suppose the chain survey can also give the right dimensions, but nowadays total station survey, we say that total station survey gives you more comfort in doing the survey. And nowadays the total station survey is also being controlled with GPS, global positioning system. So point is that equipments are of different quality and which got evolved over time. The idea is not how good the equipment is. The idea is what you are trying to get. What is the utility of that information that has to be transmitted to me, whether collected through chain survey or collected through plane table survey or theodolite or TS, total station. It is not immaterial to me. To me, the information that I need with precision or accuracy is important. Okay. So what might happen? I'll just give another example with respect to this. Let's say, see, originally what used to happen is the surveyor used to draw a uniform grid, equidistant uniform grid. If any old drawing that you would see, you will find this equidistant uniform grid, and at this intersection points they would take the spot elevations and record it wherever. See, at the edges, if the intersection point goes beyond the site, at the edge, and then okay, all elevations, spot elevations, that is recorded over here. And with respect to this, between the finding out the level, if this is one elevation and this is another elevation, let's say here with respect to this drawing, this is higher and this is lower. In such cases, if they are trying to find out one particular elevation which will be treated as a contour line, let's say 100, that 100, if I take this pink line is the true representation of the contour elevations with respect to the data that we have achieved from this particular grid line, then this point must be lying at more than 100 level. This point is below 100 level. This point is below 99. This point is above 99, below 100. So what happens is, from this particular points and trying to find out trigonometrically the relative distance and the elevations with respect to that, they will try to find out if this is 100 something plus something, then where is the point of 100? Then with respect to these two pairs, if this is 100 plus and this is 100 minus, then where is really 100? And with respect to this pair, if this is 100 plus and this is 100 minus, then where is 100? So these 3 points which will be corresponding to the 100 now will be connected. So that represents within this square that segment which is the 100 level. Similarly, go from here to this. I am just showing one more with a bigger. With respect to this, this is the location of 100. This is the position of 100. And this is the position of 100, and if you connect this, then you get this as a line called 100. So this is how the entire contour lines are extrapolated or interpolated based on the pair of dimensions of all these sides. So basically the 3 pairs. You don't have to do any other intermediate. So if you do between this pair, the first edge pair, perpendicular pair, and the diagonal pair, you get 3 points, and 3 point makes a wonderful curve. Okay. If you want more precision, of course you can find out the intermediate level over here also. And then from here to here, this is a pair, and then find out the 100. But if this particular square is pretty large in the field, then naturally to get this curve, it will become slightly difficult. If the distance is smaller, then very quickly you can attain this particular curve. But however, this is how the whole of this survey is done. So I am discussing about the concept and the fundamentals on this particular, how this survey data has to be used by us. What will happen then is that if suppose you find, for argument's sake I am saying, if suppose the whole land is flat, do you really, and there in reality there will be one contour line here and the next contour line may be at this particular end, will you be dividing into so many such grades and take the pain of doing the spot level survey of all these things? Not necessary. Then you can tell the surveyor that you can use the distance between these two by so many meters. How will you do it? You can only do it when you have gone to the site, felt it, you have seen it, you have a photo documentation, and at the site itself you have a feeling, visually interpreting and perceiving, and then through comprehension, intellection, you can say, if this site is so flat, I need not take intermediate levels. So my distance between one particular spot elevation point and the next elevation point may be quite far away, because in between if I do take any other points, it will make marginal difference in the elevations. But if suppose you find that within this there are some bit of irregularities in the topography, then if you take an elevation over here as 1, the next elevation over here, then in between whatever elevation changes which are slightly occasional at some cluster at one particular point will not be recorded in your diagram. So what happens in such case, what you do is you tell the surveyor that you take this much of grid, but only at that particular point you make further divisions, so that this particular elevation is recorded. I hope this is clear. The way the whole survey has to be done, the survey has to be guided by you, the designer, and don't leave it to the intelligence or experience of the surveyor, because the surveyor will be very true to his work. He will be very diligent in surveying. He will be very expert in using that machines and ultimately interpreting it this. But what is very important over here is what data should he bring for you? You have to guide him. This is the particular stage where you would see that the whole survey procedure becomes almost an integral part of your planning. And that planning, you know how it happens. An example, let me tell you why I said that at the reconnaissance level itself, many of your planning decisions you will take. At least I do. And if you're trying, if you're doing for the first time, try it, you'll find that yes, it will be done in the similar manner. Basically what happens is, look at this, the same sketch which I'm showing here. Suppose I had been to the site and I found that no, intermediate contour levels are not there. It is the first level here and the next level here. Agreed. So this is flat. But suddenly I found that there is something like this, and there may be a rock outcrop, and I would take note of it. Not only I'll take note of it, I'll also record it in my drawing. So I will ask him that, okay, this is one grid, it is the next grid by which I can always use it, but give me the detail of this in terms of its height, topography, contours and everything. So here, and then maybe at the site, before the survey has been done, I can also decide, oh, this particular element which is a rock outcrop, I'll use it in my landscape. I'll not destroy it, I'll not flatten it just because the entire site is flat. I will use this for very specific reasons. So I must have the full dimension of this in terms of contours, its changes, the profile, everything, so that whenever I'm working, nothing can be absolutely non-dimensional. Because here, once that particular drawing comes onto your table, you will find that everything is very, very dimensionally done. And you cannot release one drawing from your design table for construction without dimensions. You will see later, well, I'll show you some, that whenever you release one landscape drawing, apparently to impress your client, you make a very colorful presentations. The client tries to conceive or perceive what you are going to create, because that is not yet created. But the contractor who is going to execute it, he is not bothered about what colorful presentations you have shown to the client and got approval. He tries to know exactly the location of each and every item and their specifications and the quantities. So dear friend, this landscape design is not a pattern making game. I am repeating, landscape design is not a pattern making game, not a colorful exercise. Landscape design is one of the very strong technical document which is represented for approval with colors and textures and fancies. But when it comes to the brass tacks of ground reality of implementing on site, everything has to be so dimensional. Okay, in the next I will discuss about the other aspects of it. Thank you.